Okay, hi everyone. Let me work through this quick demonstration of how we can compare nominal rates to effective rates. You've got a problem written at the top, so we'll assume we have a $1,000 investment. $5,000 is the annual rate given, and which means we'll calculate $50. But let's work it through to see if we can come up with the effective rate if instead of it just being an annual payment with one payment, we'll break it into 12. Okay, now to save time, I've staged the problem in front of us. Okay, well, with Excel, we enter money that we're going to, let me say that another way. Cash outflows are entered as negative and cash inflows are positive. So we'll assume we'll put this money into an investment and we don't have it available, so we'll show that as a cash outflow. And let me bring this one to light too. So both on the annual and the monthly amount, it's 1,000 out the door. Now, the number of periods on an annual amount, which is like the nominal rate, is 1. But if we've got 12 periods in a monthly payment stream, then we're going to use the number 12 that you see here. Okay, the annual rate given in the problem is 5%. But on a periodic rate, we would have to take that 5 and divide it by 12. Okay, so you can see the formula right here from the formula bar, or if I hit F2, you can see 5% divided by 12. Okay, so it's 0.4%. And there's probably a few other decimal places hanging out there, but I'll just take it to 1. Okay, then the future value, I'm going to use a financial function to find it, and you see it here, the future value function. Now, if I hit this function bar or this button, we get the function arguments, and you can see where I'm pulling it in. Cell B13 is the rate. Let me slide this over so you can see it. I don't want to hide it too much. Okay, so the rate is 5%. The number of periods was given in B12, which is 1. There's no payments. We just have the present value of 1,000 that we're giving up. We're giving up $1,000 now. We'll assume it's a normal payment. You can make this 0 or leave it blank, which means it's a normal payment, interest occurring at the end, payments occurring at the end. And then once we have all that information, we hit OK, and we get a future value of 1,050. So to calculate the interest, we simply would subtract the difference. And since it's negative for purposes of calculating the future value calculation in cell B15, then in cell B16, I'm going to add the 2 to come up with the difference, right? So 1,050 less the 1,000 meant we had $50 of interest. And if we compute the effective rate, we simply take the amount of interest and divide it by the present value, and we see it's 5%. Okay, now, if we bring that to light using those same calculations, and I'm just going to format it the same here, what we see is the future value here is a little bit different. And the reason is we've got a little bit different values. The rate has to be the periodic rate. So from cell E13, slide right here, we see that the rate is actually the annual rate divided by 12. Okay? So there's our annual rate divided by 12. Now the number of periods given in cell E12 is 12. Again, no payments, exact same formula. The present value is still the $1,000. Entered as a negative because we're showing it's out of pocket. The type is the timing of the payment. It occurs at the end, so we make it a 0 or leave it as omitted. And Excel will tell you that. They'll give you a little bit of clue right in here. Okay? And so what we come up with is a higher future value, and that's because the effective rate is higher than the nominal rate, or higher than the stated rate, because we've got more compounding periods. Right? So the interest earned is $51.60. And again, if we then divide the interest by the amount we put away, we see that the effective rate is slightly higher. And that illustrates the effect of compounding. Okay, I hope that was beneficial. Thanks, everyone.